Hi friends, just thought would showcase some code with a simple 3.js app. 3.js is a very nice OpenGL WebGL engine using which you can do graphics programming on the web browser. So basically, this is the simple code for that. And before starting this code, I hope you have followed the video tutorials in the link given in the link and installed node.js, npm, and also Visual Studio Code. Okay, and there was one more link wherein the YouTube video tutorial shows how to deploy a simple 3.js app on the GitHub pages, and you're able to send the link to any of your friends and view it. I hope that you have looked at both of these video tutorials, because this video tutorial which I am showing assumes that you have seen those video tutorials, and once you have them working, you can come back to this video tutorial. And if you have not gone through those video tutorials, the links are below. Please go through them. One is installing Node.js and npm, and another one is deploying a simple 3.js app on GitHub pages. Okay, please go through them and then come back to this tutorial. Once you have done that, there are slight changes that I have done based on some YouTube video tutorials whose link I have given below. So what we are doing here is this is a well-known doc type HTML, lang English, and headers and all that. We have said that body has margin 0, padding 0, and overflow hidden. Now, if you don't understand CSS, you can take a look at my other playlist, which is basic level HTML, CSS, and JavaScript. You can refer to that playlist. In this playlist and in this set of videos, we'll assume intermediate level of HTML, CSS, and JavaScript understanding. So hope you understand the CSS here. And here we are saying the script is of type module, and import app from app.js. So that is what is different from the YouTube video tutorial that shows how to deploy it in GitHub. So we are having a class called app and import in the app.js, which we'll show you shortly. And we are importing that here. And what we are doing is on document loaded, we are calling a function which will just create a new object of this type class and storing it in app. And we are saying window.app is equal to app. Okay. So this will help us write all our code in a class which is more convenient. Okay. So looking at app.js, we are importing star as 3 from this CDN link of 3 module.js. This is your 3.js engine. And this is your class app from here to here. Starts from class app, starts from constructor. It has some member functions, setup world, resize, render, and finally it ends with exporting the class app. Okay. So here in the constructor, we are saying that create a container, document, create element, div. So again, please refer back to my basic HTML, CSS, JavaScript playlist if you are unfamiliar with this. So here we are saying create the div element and document body, append this div element to the document, and then we are using various functionalities provided by the 3.js engine. Okay. So if you want to write a simple app using 3.js, you need a camera, a scene, renderer. Okay. So the camera is a mathematical approximation of the real world camera. The scene is the mathematical approximation of the world, basically where you create your objects, where you make them move around, etc. And your renderer is what sort of takes this description and rasterizes it into an image that you can see in the browser. Okay. So computer graphics is creating 2D images based off of description and mathematical approximations of 3D objects and cameras. Okay. So here we are saying this dot camera. So this dot m camera. M stands for member variable. So if you're following that naming convention, you can do that. If your naming convention is different, you can do it differently. But this helps clarify that the class app, this dot m camera is a member variable of this class, and we are saying new 3 dot perspective camera whose field of width is 60, whose aspect ratio is inner width into inner height, window dot inner width, window dot inner height. That is the browser's width and height, the display area's width and height, and 0.1 is the near z and 100 is the far z. Okay. So right now you may not understand what actually these parameters do. We'll have a short video wherein we explain some OpenGL concepts, some WebGL concepts, some how the camera is simulated, how the objects are positioned, what is the coordinate system. So all the math involved in building a 3D scene, we'll create a video for that shortly. But this is just an introduction to 3.js and a sample application. So here we can just say that this is creating a mathematical camera, and here we are setting its position to 0 along x-axis, 1 along y-axis, and 50 units along z-axis. So WebGL is a right-handed coordinate system. If you put your thumb, the index finger, and the third finger, if you expand them, and if you point your thumb to the right and your index finger up, the third finger, center finger will be pointing towards you, and that is the XYZ coordinate system. Again, we'll cut a video for that. For now, you can assume that this is a 3D coordinate system and camera's position is getting set. Then we are creating a scene, and we are saying its background color be 0x RGB. So 44 for R, 44 for G, and 44 for B. So it goes from 0 to 255 RGB color, red, green, blue. Each red, green, and blue can have value anywhere ranging from 0 to 255, and this is a hex code. So FF means 255, and these are all base 16 numbers. Okay, 0x is for hexadecimal. Okay, and we are saying create a renderer, which is a WebGL renderer, and with anti-aliasing set to true, that is as less jaggies as possible. and sRGB color space. We are saying set pixel ratio to window device pixel ratio. If it is greater than 2, we are saying no, cap it to 2. And we are saying renderer set size to inner width and inner height, and renderer physically correct lights is equal to true. A detailed explanation of all these parameters will be given in future videos, but for now you just understand that these are all properties of the renderer, which will take the 3D scene and it will give you a 2D image based on the settings. Okay, and once you have you have created the container, that container and the renderer will have its own DOM element. So again, for DOM, you refer to my previous playlist on essentials of HTML, CSS, and JavaScript. There we have explained what is DOM. So this renderer is having a DOM element, and that is getting appended as a child to the container, which is nothing but a div. So this is the child of the div, and div is the child of the body. So that is how the hierarchy is working. And we are calling this .setup world, which we'll see shortly, which will sort of create the geometry, the lights, all the digital world which you are trying to render. And we are doing when the browser is resized, we are saying call this resize this class's resize function with this as the scope, so that we can access all the class apps member variables. So if you look at the setup world, we are saying that the renderer set animation loop this dot render bind this. So there is a function called render here that will render the frame at 30 fps or 60 fps, whatever is achievable. Okay, so in computer graphics we continuously render frame, right? So every 1/30th of a second or 1/60th of a second, depending on the complexity of scene, our sort of view is refreshed. Okay, that's how we are able to create animation and all that. Okay, so again we'll get into detail of what is refresh rate, what is vsync and all in little bit future videos, but for now it is enough to understand that this function render will be called either at 60 frames per second or 30 frames per second, depending on the complexity of your scene. Okay, and we are saying ambient light. So ambient light is some light which doesn't come from any direction. It can be considered as skylight, approximation of a skylight. We are saying the skylight will be this color, ground, the light bounced off the ground will be this color, and the intensity will be this, and we are adding it to the scene. Okay, similarly we are creating a directional light. You can think of it like the sun, which has only the direction. The position is so far that the position doesn't matter. Even if we set the position here, the direction matters because this will be pointing to the 0, 0, 0 of the coordinate system. So direction matters for the directional light. Position doesn't matter because it's always pointing, no matter where your position is, it points to 0, 0, 0. Therefore its direction is what matters, and we are adding that to the scene as well. Then to create a mesh, you need the geometry and the material. Okay, geometry is basically what is the physical physical shape you're trying to represent. Material is what is the kind of reflectance property or the surface shading property does the material have. Okay, so for now we are taking a ready-made torus knot geometry which is available in 3.js engine, and we are giving some parameters. Again, you can look at just Google for torus knot geometry 3.js and see what these parameters are. And we are saying material is mesh standard material, which has a color red, roughness 0.1. See, if roughness 1 means it's very rough, if it is 0 means very smooth, right? So roughness 0.1 means it's very smooth, and metalness means if it is 0 it is completely plastic, if it is 1 it is completely metallic, right? So metalness 0.1 means it is almost plastic, right? And based on this geometry and material, we are creating a mesh called this dot mesh, and we are supplying it the geometry and material, and we are adding the mesh to the scene. Okay, so the scene has an ambient light, a directional light, and a mesh. Okay, so these are the three things that are there in our digital scene. Okay, now when you resize, we are recalculating the camera's aspect ratio based on the width and height. We are updating the camera's projection matrix. Again, we will create a video on what is the projection matrix, why it is necessary, and so on and so forth. And we are also setting the size to window inner width and inner height because it would have changed at that point of time when you resize the browser. Okay, and render is just saying renderer.render. So the renderer is the WebGL renderer which you have created here. We are just saying render this scene and this camera. Okay, so this is a simple 3JS.app. You might not have understood in depth what is a camera, what is the mathematical model, what is torus knot geometry, can I create a box geometry, can I create a sphere geometry. All that is possible, but the point of this video was to just show you a simple app that runs on your XAMPP local browser, and also you can put it on the GitHub pages, and we can showcase it to our friends. Okay, so in the local browser you can see that localhost dist, it is looking like this. So this is your torus knot. It has the red color and the directional light and ambient light lighting it. So this is how it looks. Of course, there is no movement here. I cannot change my camera angle. All that we'll do shortly. But as I said, this video is to just showcase a simple 3JS app. And also we have put it on GitHub. So okay, I can close the developer tools. So from github.io you can sort of upload it to your GitHub account and look at it in your GitHub account. Okay. So that's it, friends. I will continue with more videos later. Thanks.